All right, so this is a quick review on linear programming. And so remember, with linear programming, there are a bunch of what are called constraint inequalities. And so they end up being a system of inequalities. And you can see them graphed here. There are 4 different inequalities that are graphed there, and they, again, make up what are called our constraint inequalities. And then they give us what's called the feasible region. The feasible region is all the possible solutions to this system. And what we're concerned about in the feasible region are the corner points. Because what we want to do with our linear programming is we either want to assess a maximum situation or a minimum situation. Now you'll be told this. We also have what's called the objective function. The objective function is what allows you to assess the maximum or the minimum. We're going to treat this as a maximum. To do that, what we need are the coordinates of the 4 corner points. All right, so our first point here is what? 560. So 560. Our second point right here is what? 580, right? 580. Our third point, as I work from left to right, is right here at 870. 870, and our fourth corner point is right here at 1050. 1050. Okay, so now we've got our 4 corner points, and that's what we wanted. So we got 560, 580, 870, and 1050. Now remember, each is an x coordinate and a y coordinate, and so we simply substitute in the values, x for x and y for y, into the objective function, and we solve. All right, I'm not going to take the time to show the substitution. We should be able to do that at this point. We end up with 5 times 15 is 75 plus 60, and so the first one gives you a value of 135. Plug in the second set of coordinates, 580, and now we get a value of 155. Plug in the third at 870. 8 times 15 is 120, plus 70 is 190. And then we plug in the last set of data here, and we get 150 plus 50, or 200. So this is a maximum at 1020, or excuse me, 1050, the point 1050, and the maximum amount is 200. Okay, and look, it's not, we're doing a maximum. Did it end up being the highest point? No, it didn't. It didn't end up being the highest point. It all depends it really on the objective function. The objective function is going to give you insight as to where your max is going to be. Now, if we were doing a minimum, it would have been 560 for a minimum value of 135. So let me review again what we've got here with linear programming. We have constraint inequalities, right? They constrain you. When you graph an inequality and you shade, we end up shading the feasible region. We then, in that feasible region, we want to look at the corner points. And you can see we looked at the corner points. We get the coordinates of those corner points. We put them into the objective function, and substituting those corner points into the objective function, we can then figure out the value. If we're looking for a max, we want the most value. If we're looking for a min, we want the least. Hey, that's linear programming.